Hey guys, welcome back to the channel. Today we'll be solving LeetCode 1046 last stone weight. So we're given an array of integers called stones where the stone at each ith position is the weight of that stone. And we're going to play a game. So on each turn, we're going to choose the two heaviest stones where y is going to be the heavier stone and we're going to smash them together. So at any case, y can either be greater than x or it can be equal to x. If equal to x, we're simply going to destroy both stones. But if they're not equal, which means y is greater than x, then we're going to basically smash them together and the product is going to be y minus x. So whatever is left over is going to be the difference of the two weights of the stones, and we're going to push that back to our array, and we're basically going to keep doing it until we either have no stones left or there's one stone left. And if there's no stone left, we're going to return 0. If there's a stone left, we're basically just going to return the weight of that stone. So there's going to be three different ways to solve this, and the best way or the optimal solution is going to be with a max heap, which is going to have a time complexity of n log n and a space complexity of O of n. So let's get into the explanation now. So the reason that the time complexity is going to be n log n is because at every iteration we are going to be pushing and popping from the heap. And as we know, popping from a heap is constant time, but pushing to a heap is log n times. So we're going to be pushing to the heap n times. That's why it's n times log of n. And the reason it's going to be linear space complexity is going to be because we are storing the heap, and that is not part of the result. After converting our array to a max heap, which we're going to do by using negative values because Python does not have a built-in max heap class. So we're just going to negate every value, and the largest values are going to be the smallest because they're negative and they're going to come to the top. And this is basically what our max heap is going to look like. So let's get into the example where we can better illustrate how this is going to work. So at every iteration, we're simply going to get the two largest stones, and that can be done in constant time when using a max heap. And we can do that like this. We're basically just going to grab the largest value, which starts at 8, and we're going to grab the next largest value, which is going to be 7, and we're going to smash them together and we're going to get 1. And then we're going to push that 1 back to the heap, but if it was 0, we would not push anything back to the heap. Then we get the next, this is what the heap is going to look like in our next iteration. As you can see, there's 3 ones this time instead of 2 because we pushed this one, and we're going to get 4, which is our largest, and our second largest, which is 2. So this is going to be x and this is going to be y. We're going to smash them together and get 2, and we're going to push it back to our heap. Then at the next iteration, we're going to get 2 as our largest and 1 as our second largest, smash them together and get 1 and push it back to the heap. Then we get our largest, which is 1, and our second largest, which is also 1. We smash them together and get 0, and we don't have to push back anything because it's 0, and we are left with 1. So this was the case where we have a stone left over, so we can simply return the weight of it instead of returning 0. But if there was nothing left over, we would return 0. So let's get into our code now. So before we convert our stones array to a heap, we have to negate every value in the array because Python does not have a built-in max heap class. So we can just do that like this. So for every stone, we're going to negate it using a for loop. And then we're just going to use Python's built-in heap queue class to heapify our array like like this. And as long as the length of our heap does not go below, or it stays greater than 1, we're just going to keep iterating. Then we're going to grab two values, and we're actually going to grab the largest value first because the heap stores we can grab the largest value first using the heap, and that's going to be y. So we're going to grab it, and before we grab it, we're going to negate it because we are negating it, but we want them to be positive. And we can use that using heap pop from heap q. And then we're going to grab the smaller value, which is going to be x, and we're also going to negate that. And if these two values are not equal, which means y is greater than x, then we're going to push back their difference to the heap. And we can do that using heap push. So this is going to be the heap which we're pushing in. The second value is going to be the value being pushed. And before we push it, we're going to negate it because this is a max heap implemented using a min heap. And this is pretty much our entire while loop, and we can just return after that. But before we return anything, we have to check, is there anything left over in our heap? And we can do that using this. So if there's anything left over, we're going to return it. We're going to return its weight. But if there isn't, so if there isn't anything left over, we're going to return 0. And this is pretty much all our code, and it should work. And as you can see, it's pretty efficient, and it's going to run in n log n time with O of n extra space. Thanks for watching.